All right. Good morning, everyone. My name is Logan Bell, and I am a software developer for Mediamath. And as my slide happens to say, I'm going to be giving a talk on immutable deploys. Essentially, for the last 6 months, I've been doing a lot of head-to-desk when it comes to playing around with Packer and Terraform. And this talk is basically presenting all of the knowledge that I've gained in the last 6 months to hopefully help someone out who wants to set up a continuous deployment pipeline using these tools. Like I said, this talk is primarily about Packer and Terraform. These two products are built by a company called HashiCorp. They're relatively famous for another tool called Vagrant, and they have a few other products as well. Packer is primarily a tool that's very similar to Vagrant in nature, but uses a different sort of configuration file. That it is used to essentially create production images. And I'll go through some demonstrations how it works. The big advantage to using Packer is that you can do parallel builds. So you can actually build Docker images and Amazon AMIs. And it's also an open source tool. Terraform is kind of the flip side of Packer. You would use it to essentially launch an entire infrastructure and manage your production environment. We use it for integrating with Amazon, and most of my examples will be demonstrating its usage with EC2. So let's talk first about Packer. So Packer is basically it's just a command line tool called Packer. And it is built to parse and read a template file. This template file is primarily written in JSON, and there are 4 main components that are a part of this file. It is composed of things called builders, post-processors, provisioners, and variables. Builders are the things that you can run in parallel. For example, you can build, as I mentioned, you can build Amazon EBS images, Docker images. It integrates with OpenStack. The things that are post-processors are the things that after you provision or build an image, you can, as it's kind of self-descriptive, you can run a post-processor across it. Common sorts of things you want to do is archive your image, which is very important for a continuous deployment pipeline. Provisioners, these are the actual nuts and bolts of everything you want to get installed on the box, your web application, etc. And then finally, variables. These are just sort of the things that you can pass in through a command line, either through environment variables or actually a command line variables. So here's an example of a basic template. And can everyone see that okay? I just realized, okay. The first section here is, as I described it, setting up some variables. So this one is going to build an Amazon image for us, and we needed to specify an AWS access key and secret. So it's going to read that information from the environment. The next section takes an array of builders. We're only using one builder here, which is the build the Amazon instance. And you can see down below the access key. We are basically using the variables that were defined in the prior block. And then an important aspect is the source AMI. This is the AMI that it's going to use to build. And this particular one is in Ubuntu source AMI. And then the last thing down at the bottom there, an AMI name. So when it's done provisioning, it's actually going to save this off into EC2 as this name down here, Packer-example, and it's using a special built-in variable called timestamp to place a timestamp there. So to build this, Packer just has a couple commands. I'm only listing 2 here, but Packer validate will basically just parse the file and verify that it is valid, and then build will actually go out and start building it. So I'm going to attempt to do a live demo here, and we'll see how this goes. There we go. So we can run, oops, in the wrong directory. This is relatively, this may take a few minutes, but I'll let that run in the background. But basically what it's doing, as I was mentioning, it's spinning up an instance on Amazon to build out this, this AMI. We will come back to that shortly while it's doing that. Okay, and then the third part of, probably the most important part is the provisioners. In this particular provisioner, we're not really doing anything special, but it's using a shell type, and you can run inline commands. You just supply whatever commands you want to run. This one is just installing a few things, Perl and Apache 2. You can also do such things like, first example is using the inline as well, but the second one there is you can use scripts, so you can just write a bash script and it will run that. It comes with other types of provisioners. One in this example is an Ansible provisioner. It has chef provisioners. It has a whole number of them. And this one here is basically, we're just pointing it in the direction of a playbook, which is an Ansible. Basically, it's like a list of things to do, and it will run Ansible. The one caveat is that it expects Ansible to actually be installed in the AMI, so that's just one gotcha that you have to kind of think about. Even though they have these built-ins, you have to also install the particular thing you're trying to use. Here is something that's a little bit more useful. This one here is actually deploying or actually provisioning a real application. We have two types at the top there, the two file types. So essentially what we're doing is we're copying the file from locally out to the box, and we're putting it in the temp directory. So we have a myapp.pl, which is just essentially a dancer app, which I'll show here in a minute. And then we have a supervisor D configuration file, which is just going to turn on the dancer app for us. And then finally, we run our provision script. And if we take a look at the provision script, essentially it's just a bash file, and it's hard to read, I realize. However, basically the script, that the dancer app is just a fat-packed dancer application, so it's just a single file. We install some things here like cpan minus, so that we can install, some of the things that have C dependencies. And then down below, as you can see in the previous screen, we copied those PL and the supervisor conf files into the temp directory, so this is actually placing them where we want them, so we can run it, and then we spin up supervisor. This is the dancer application. Nothing sophisticated here other than just the example from their page. And if we go back to our demo here. Okay. So in our previous demos, we see that it actually created the artifact, and you can see that it created the AMI image for us. And if we logged into EC2, we could actually go and see that image. But what I want to do now is I want to run the one that we just went over, which is basically going to create an image that's more useful. And we'll use that later here. So this is going to, as I mentioned, it's going to actually install Dancer on an AMI and save it off for us. So we'll let that run. We'll come back to it in a minute here. Okay, so as I mentioned, you can do parallel builders. Docker's the new thing. So this is an example of doing, we're building out an AMI and then also at the same time creating an exact same provision but saving it off to a Docker image, which is entirely possible to do. Let's talk a little bit about post-processors. So as I mentioned, this is important for, there's all sorts of things you can do with post-processors, but the primary thing that I use them for is to save the image off somewhere. There's another service actually that HashiCorp provides, which is called Atlas. They have a free and they also have a paid service, but basically they allow you to set up a continuous pipeline. So after we build an AMI, we will then run a post-processor to save that AMI off into the registry. Then later with Terraform, we'll go and find that AMI and use it to provision our environment or our infrastructure. Here's another one. This one's really hard to read, I'm realizing, but basically this is a post processor that takes a Docker image after you've saved it, and let's say you want to push it out to a Docker repository. This one's using the Amazon ECS service, so you can put it out there on Amazon ECS, and then you let ECS take it and deploy it for you. Okay, so let's talk a little bit about Terraform. So as I mentioned, Terraform is another tool. It's a command line tool. It's called Terraform, and it reads a configuration file. This configuration file is not primarily JSON, although you can write it in JSON. All of their documentation is using this sort of custom DSL that they've written. It's not difficult to read once you kind of get the gist of it. Primarily, it's made of two basic components. You have providers and you have resources. A provider is just the thing you're trying to integrate with. Many examples are like the Google Cloud stuff, or AWS and Docker. A resource are individual components within there that are specific to that provider. So a good example is like on Amazon, you want to set up an instance, or you want to set up an elastic load balancer, many sorts of all the various security groups, whatever you need to do that's specific to Amazon, you can define it within a resource. So here is a very basic Terraform example. Like I said, there's a provider at the top where we're defining a few things. And the region is important. This is where, where is this going to live? What we're tying, where our instance is going to live. And then we have a resource here, which is basically what we're saying is, well, I want to use the resource AWS instance. That's a very specific resource. And then it's followed by the name of this thing. And we can use that name later in variables that we reference in other resources. So I'll go over an example here where you can set up a security, or you can set up you can reference a security group into an instance, or you can reference an ELB. You can set up an ELB that references a particular set of instances and those sorts of things. So this one here, we're using an AMI that we've saved off somewhere, and the instance type is an M3 medium. That's just an Amazon terminology. They have various different types of instances that you can pay for. Some are free, some are not. It comes with a number of commands. The primary one is Terraform apply. That's the one that actually will just go out and build things. And then it also, after you run apply, it generates a state file. The state file is important to keep around. You want to check that into your GitHub repo, or if you're using Atlas, you want to push it out to Atlas. This is the state of your infrastructure, what is currently in production. Terraform destroy will just destroy it. Validate is very similar to Packer validate, in that it's going to validate your configuration file. Terraform plan is actually very useful. It will essentially, if you make a change to any of your configurations, it will basically, it'll show you what the change is going to happen before it actually does it. So you can also generate plan files, which is kind of useful. Terraform push is another command where you can take the state file and push it to, you just push it to Atlas essentially. And it will use that state file. So if you're setting up a continuous deployment, it would use that. So it would detect when you get a new AMI that's built by Packer. And then it would take that, it would verify that the state has changed, and then it would provision that new AMI to production. Okay, so here's an example, as I mentioned, of another resource of a security group. There's a lot of details in there, but the primary thing is, this is very specific to Amazon. All of these sorts of properties you can set. It's, you can go and look at their documentation. But basically, most of the stuff that they integrate with, they support. So like in Amazon, security group is important to set up your ingress and egress rules. In this particular one, we're accepting traffic on port 80, and we're allowing traffic out on 112.1.1. Here's an example of setting up an elastic load balancer, which is just a load balancer. We accept traffic on port 443, and our instances are running on 8080. Okay, so one of the interesting things about Amazon is they also have these things, which this actually works really nicely with Terraform, especially when you're trying to do hit list deploys. And a hit list deploy is essentially when you're trying to not drop connections. So when you are, for example, you have a new AMI and you want to put it out in production, you want to basically roll things out in such a way so that the new ones come on first, and then it kills off the old ones without dropping connections. And so a nice side effect of using AWS launch configurations, and we'll see shortly which goes with them, is AutoScaling groups. You can do that. So here we're setting up a launch configuration, and basically the whole point of it is you can set up a pool of instances, and you can, it can auto scale accordingly. So depending on various triggers you can set up, traffic needs, or also deployments. So in an auto scaling group, you can set up like a minimum size, a maximum size, and this one's sort of basic in that it's not really doing any sort of like scaling other than we're using it for doing sort of a hit list deploy. Okay, so why don't we go back to our live demo here. Okay. And what I'm going to do is I'm going to actually run something. I'm going to run Terraform plan. And that's not going to come up very well because everything's zoomed out. But essentially what it's let me see if I can get my mouse over there. What we're doing here is we're setting up a security group, we're setting up a public key, and we're setting up an instance. So if we do Terraform apply, we're going to actually create this. And this will only take a couple seconds. So it's going out, grabbing the AMI, and creating this instance here. Should only take 15 seconds maybe. I'll let that, I know it doesn't go past 20 seconds. There we go. Okay. So now we can run, as it says, you can run Terraform show. And this is the state of our environment. And go up here, looking for see how well I can do this. Okay, let's copy this public IP. Okay. Yep. So let's just replace this guy. So if, might have to give it a second here, hopefully it's up. Oh, it's not up. It takes a second, but basically it is provisioned that dancer application that we have. The supervisor may still be, or the operating system may actually still, there it goes. There we go, okay. So now we have an actual live box. Okay, so now, go back to my mouse. So the one thing I do not really have time to go over in this topic is Atlas itself, but essentially you have the two tools that allow you to build a continuous deployment pipeline. You can create an image with Packer, save it somewhere, and then you can with a little bit of scripting you can then use that AMI, get that AMI, well not an AMI, whatever sort of environment or image you've created, you can use that to then use Terraform to create your infrastructure. Atlas is just a service that makes it easier. So that's just something that you can go check out. I will have the links to this talk provided at that particular URL. And like I said, I work for a company called Mediamath. We're always looking for, just giving a little plug here, we're always looking for good developers, people who are interested in not just programming, but also the sorts of things like DevOps. And then all these tools that I've been talking about are provided by a company called HashiCorp, and they're all open source. And that is all I have to demonstrate. Does anyone have any questions? Jim?
Can you just explain a bit about the word immutable in your talks?
Yes. So this talk is sort of assuming, essentially, an immutable deploy is instead of deploying the application to, it's a loaded term, but the general idea is instead of deploying the particular application and configurations to an already running computer somewhere and changing it, you are essentially creating an image. So the idea is, in my examples here, we're actually creating an image or a box, a machine that is going to replace the machines that are in production. So that is my definition, or that's sort of the definition I was running with immutable deploys. Yes?
So I've used quite a lot of vagrants. Where does that fit in this?
Well, so this is the thing. I've used Vagrant as well. Vagrant, I've actually never really used Vagrant for production. So I kind of see Vagrant as the tool that allows you to build out things for development. But that's just me. I think you can probably use it for production. I think they designed Packer essentially for the continuous deployment side of things, and creating images for production. But the tools overlap. Yeah.
Can it work on bare metal, like create images and then deploy to bare metal?
That's a great question. I have not even explored that because everything we've done is all virtual, but don't quote me on it. I believe you can do some of it, but you'd have to go and look. Terraform?
Terraform can deploy to bare metal.
Okay. Well, there you go. All right. I'm all done. All right. Thank you, everyone.